Hello students, welcome to Saurav Sir's classes. The topic of this video is inequalities. Now, in mathematics, an inequality is a relation. It is a relation that holds between two values when they are different. So, when they are different. So, it can be not equals to. So it is one of the inequalities which is not equals to. But here we cannot say whether one number is greater than or less than the other number. Next is, so this one is not equal to. Next is less than. So if there is this notation between A and B, so it says that A is less than B. Similarly, this is greater than. So if A is this notation B, so we say that A is greater than B. Similarly, now these two inequalities are strict inequalities. So we can also say that when it is written that A, this symbol, and B, so we can say that A is strictly less than B. Similarly, here we can say that A is strictly greater than B. So these two are strict inequalities. Next two are not strict inequalities, they are less than equals to, less than or equal to, or equal to, and the next one is greater than or equal to. Now this less than or equal to it is also equivalent to not greater than. Similarly, this greater than or equal to, this is equivalent to not less than. So these are the other two inequalities. So what we have learned, that inequality is a relation. It is a relation between two values when they are different, that is, they are not equal. So the first notation is not equals to 0. Here we cannot determine whether one value is greater or less than other. Next is less than or greater than. These two are strict inequalities. So we can also add this strict in the definition, that is, A is strictly less than B, and or A is strictly greater than B. So now next is less than or equal to. So when we write A, this symbol B, so this means that A is less than or equal to B, or A is not greater than B. Similarly, when we write this A greater than equals to B, so this means that either A is greater than or equals to B, or we can say that A is not less than B. Now we will learn some elementary properties of inequalities. Now the first property is, that is property 1. It is that if A, B and C are real numbers, so they are real numbers such that we have our A is greater than B. So if we have our A greater than B and B greater than C, B greater than C, then A is greater than C. So if we have three real numbers A, B and C such that our A is greater than B and our B is greater than C, then this would imply that A is greater than C. So now more generally if A1, A2 so on till AN, so these are some n real numbers such that A1 is greater than A2, A2 is greater than A3, A3 is greater than A4 and so on till AN minus 1 is greater than AN, then we can say that A1 is greater than AN. Now the next property says that if A and B are real numbers, so if A and B are real numbers, so they are real numbers such that A is greater than B, then this would imply that A plus C is greater than B plus C, where C can be any real number, so that is for all C belonging to R. So if A and B are two real numbers such that our A is greater than B, then this would imply that A plus C would be greater than B plus C, where C can be any real number. Also, it would also imply that our A minus C is equals to B minus C, where again C is any real number. So basically if A is greater than B, then A plus C is greater than B plus C, where C is any real number. Similarly, A minus C is greater than B minus C, where again C is any real number. Next is property number 3. It states that if A and B are two real numbers, so if they are two real numbers, then now such that A is greater than B, so this would imply that A into C is greater than B into C. So if A is greater than B, then it would imply that AC, that is A into C, is greater than BC, so that where C is a real number, that is C is any real number greater than 0. Similarly, A divided by C is also greater than B divided by C. So, when A is greater than B, then AC is greater than BC, or A by C is greater than B by C when C is a real number greater than 0, that is, it is positive real number. And AC would be less than BC, or A by C would be less than B by C when C is less than 0, that is for all C less than 0, where C is a real number. Now less than 0 means C is negative real number. So when C is positive real number, then if A is greater than B, then AC is greater than BC, or A by C is greater than B by C. But if C is negative real number, then if A is greater than B, then AC would be less than BC, or A by C would be less than B by C. Now next is property number 4. It states that, now suppose if A is greater than B and B is greater than 0, that is, these two are positive real numbers, that is A and B belongs to R. So in that case, 1 by A would be less than 1 by B. So what's happening is, if A is greater than B, then 1 by A is less than 1 by B, where both A and B are positive, that is, they are greater than 0. Next is, that is property 5. It states that if A1, which is a real number, it's greater than B1, another real number, A2 is greater than B2, A3 is greater than B3, and so on till AN is greater than BN, then this summation of A's, that is A1 plus A2 plus so on till AN, this whole summation would be greater than B1 plus B2 plus so on till Bn. So what is it? That is, A1 is greater than B1, then A2 is greater than B2, and so on till AN is greater than Bn. Then if we sum all of these, that is A1 plus A2 plus so on till AN, then this would be greater than B1 plus B2 plus so on till Bn. In the next property we have A1, A2 so on till AN, and B1, B2 so on till Bn. So these are two sets of positive real numbers, positive real numbers. So they are positive real numbers, so that is, they are greater than 0 since they are positive real numbers. So suppose A1 is greater than B1, A2 is greater than B2, and so on till AN is greater than BN. So if this is the situation, then A1 into A2 into A3 so on till AN, this is greater than B1 into B2 into so on till Bn. So if A1, A2 so on till AN and B1, B2 so on till Bn, if these are positive real numbers, two sets of positive real numbers, that is, they are greater than 0, such that A1 is a1 is greater than b1, a2 is greater than b2, so on till an is greater than bn, then we can say that the product of the left hand sides, that is a1 into a2 into so on till an, is greater than the product of the right hand sides, that is b1 into b2 into so on till bn. So if a and b are positive real numbers, that is a and b are greater than 0, and a comma b, they belongs to r, a real number, such that a is less than b, then so if a and b are positive real numbers and we have our a less than b, so if n is any positive rational number, so n is a positive rational number, then we can say that, so if a and b are two positive real numbers and n is a positive rational number, so if we have our a less than b, then we would have, or this would imply, that a raised to the power n is less than b raised to the power n. Second is, so this is the first so the first result, that if a is less than b and n is a positive rational number, then a raised to the power n is greater than b raised to the power n. Next is a raised to the power minus n. This is greater than b raised to the power minus n. So here, when a minus sign would appear before n, then the sign would change, that is internal sign would change, because a raised to the power minus n is equals to 1 by a raised to the power n. Similarly, b raised to the power minus n is equals to 1 by b raised to the power n. Now if a raised to the power n is less than b raised to the power n, then 1 by a raised to the power n, this would be greater than 1 by b raised to the power n. So this would imply this, which would imply that our a raised to the power minus n is greater than b raised to the power minus n. And the third one is that a raised to the power 1 by n, this is less than b raised to the power 1 by n. That is, if our a is less than b, then nth root of a would also be less than nth root of b, where our a and b are positive real number and this n is a positive rational number.